Okay, welcome back to some more fun-filled math. In this video, we are going to talk specifically about rationalizing denominators. Rationalizing denominators is a math concept that we use when you have a radical, so whether it's a square root, cubed root, fourth root, etc., in the denominator of a fraction. Okay. Well, we can't leave the radical in that denominator, so instead we have to do what's called rationalizing. Rationalizing says you have to multiply both the numerator and the denominator by whatever the square root is that's currently in the denominator. Then you simplify as far as you can, thus leaving behind just a straight constant in the denominator. So I've got a couple examples here that we can look at. So these are rationalizing if you have a single term denominator. So if we look at this first one, notice I have a square root 5 in the top, which is fine, but I have this square root 7 in the bottom. This I cannot have. So what I have to do is I have to take my given fraction, so the square root of 5 over the square root of 7, and I have to multiply top and bottom by the denominator. So I'm going to multiply top and bottom by the square root of 7 over the square root of 7. Now with our multiplication rules, we know that as long as your index is the same, you can take two radicals and you can combine them under a single radical through multiplication. So here, what I actually have is I have one fraction where I've got on the top the square root of, and this is going to be 5 times 7. And then I have a single radical on the bottom, and this is going to be 7 times 7. So if we continue to reduce, 5 times 7 is 35. So this is going to be the square root of 35. And 7 times 7 is 49. So this is going to be the square root of 49. Now the first thing we have to do is look, and can I reduce my numerator down any further? Well, in this case, no. There is no perfect square that I can pull out of 35 that's going to make this any smaller. So that means in terms of my numerator, I am left with the square root of 35. However, the square root of 49 itself is a perfect square, which gives me 7 on the bottom. Since my radical has gone away, I have successfully rationalized my denominator. In the second example, notice my index here is cubed. And the biggest thing that we have to remember about cube is that cube says we're looking for a group of 3. So the first thing that I want to do is I want to look at the bottom. Bottom is the cubed root of 25. So I have the cubed root of 16, which I'm leaving alone for the second. And I can break 25 down. So this is actually going to be the cubed root of 5 times 5. So this is actually a group of 2. However, I need it to be a group of 3. So if I'm looking just at the bottom, what is missing? Well, in order to make this a group of 3, it means I'm missing a 5. So I have to multiply the top and the bottom by the cubed root of 5. So when I do that, what happens is across the top I have the cubed root of 16 times 5, and across the bottom I have the cubed root of 5 times 5 times 5. So we know 16 times 5 is going to be the cubed root of 80. And I know that 5 times 5 times 5 is technically 125, but what I also know is that I have my group of 3 here. Therefore, what pulls out is 5. Now, when I'm looking at 80, I know 80 can break down. So if I'm looking at how it can break down, I'm looking at 80 breaking into, say for example, 10 times 8. And in this case, 8 is a perfect cube. Okay, so with this being a perfect cube, it means 8 actually becomes 2 times 2 times 2. And there, right there, is your perfect cube. So what pulls out is going to be a 2. And what stays behind is the cubed root of 10. And remember, the whole thing was still over 5. Now if we look at 10, 10 is not going to break down any further. It does not have a perfect cube that goes into it nicely. Therefore, it is reduced down as far as you get. And this would be your rationalized denominator. Now the other thing that we have that we can do is called binomial denominators. When we have a binomial denominator, in order to rationalize it, says that you have to multiply by the conjugate, which means you have to multiply the numerator and the denominator by the opposite sign of the given binomial. So in this case here, I am looking for what's called the conjugate. And my conjugate is going to be the opposite sign of what is seen here. So this is going to be the square root of x, and I have the square root of 2. I am subtracting, so the opposite sign here would be to add. So I have to multiply by the conjugate. So to do that, says I have to take my numerator, square root of x, over my current denominator, square root of x minus the square root of 2, and I have to multiply it by that conjugate, square root of x plus the square root of 2, and the square root of x minus the square root of 2. Again, your multiplication rules says that we can combine across the top, so this is actually the same as saying that I have the square root of x times square root of x plus square root of 2 over square root of x minus the square root of 2 times the square root of x plus, the square root of 2. Now, when we're talking about the top here, we are talking about distributing. So we got to take this square root of x and we got to multiply it into both sides. When we talk about the bottom here, we are talking about foiling, first, outer, inner, last. The biggest advice I can give you would be to do your FOIL first, because if you've made a mistake, the mistake is with your conjugate. And therefore, since the whole goal is to make sure that all radicals disappear in the bottom, if you made a mistake with your conjugate, you might as well find out quickly. So I would FOIL these two together before doing anything with the top. So when we look at that, FOIL says first, outer, inner, last. So first is my first terms. So I'm going to have the square root of x times the square root of x. Okay? So that is going to be my first. Then I have to do outer, which is going to be adding to the square root of x times the square root of 2. Then I have to do inner. So I'm going to add this to negative square roots of 2 times the square root of x. And then I have last. So this is negative square root of 2 times the square root of 2. Okay. And this is still the square root of x times the square root of x plus 2, because square root of 2. Because I haven't done anything with it yet because I'm checking. Now, what do I know? I know x times x is x squared, so this right here is going to become an x. I know that I have plus the square root of 2x, and then I have plus a negative, so this becomes minus the square root of 2x. And then here, plus a negative again becomes minus, and then I have 2 and 2, which is 4. Take the square root of that, and you get 2. If you look, this term right here in the middle will totally disappear. And so what we're left with is just simply x minus 2. Therefore, all my radicals in the bottom disappear. So I actually have the square root of x times square root of x plus the square root of 2 all over x minus 2. The last thing that I need to go ahead and look at is doing that distributing we talked about earlier. So that says I have to distribute in. So this is going to become the square root of x times the square root of x plus the square root of 2 times the square root of x. And the whole thing is over x minus 2. Well, we know, again, just like from earlier, x times x is x squared. Take the square root and you end up with an x on top plus, and then here I'm going to have the square root of a 2x, and the whole thing is over x minus 2. And this becomes my rationalized denominator. Okay? So those are some examples of being able to rationalize denominators depending on the different types you were given, whether you were given a single denominator to work with, a single term denominator, or you're given a binomial denominator, both of which can be rationalized. Remember, rationalizing a single means you have to multiply top and bottom of your fraction by whatever that radical was. However, to rationalize a binomial, you have to multiply by the conjugate, which means the opposite sign of your equation. So if you have any questions, please make sure that you let me know. Otherwise, remember, all math is bananas. So please keep smiling. Make sure you ask tons of questions. The bottom line is to have lots of fun with your math, and as with everything else, I'll see you next time.